I'm going to show you some upgrades that'll boost your miter saw to give you square, accurate cuts that are repeatable, produce little to no tear out, and make way less dust than the factory setup. The first upgrade that I think will make a much better experience is upgrading the dust collection. Miter saws, as you know, generate a lot of dust, and most come with very little to no dust collection setups. Now, I've seen a lot of videos with some pretty good DIY solutions like making or purchasing a dust collection hood or coming up with other designs specific to your saw. Then I came across Shop Nation's channel and watched some of his videos on his 3D printed designs for custom dust collection systems. I could tell that he put a lot of thought into these designs and figured for the amount of money he was asking for the setup, it was definitely worth a shot. So I decided to purchase the setup for my particular saw, which is the DeWalt DWS 780, and at the time of making this video, the setup costs around $50. And as I was on his website, I saw that he has other miter saw custom dust collection setups that he designed, available for Ridgid, Bosch, Delta, and even the Harbor Freight Hercules saw, which I thought was pretty cool. I ordered it on a Sunday and it arrived the following Wednesday, and after watching a short installation tutorial, I was able to install it very quickly. This setup replaces the current not so good dust collection port that comes with the saw. And for a few extra dollars, he'll throw in a couple of different adapters for different vacuum hose sizes. Here I am using the saw with the stock dust collection setup. And here I am using the saw with the upgraded dust collection setup. Again, super pleased with this. A shout out to Travis at Shop Nation for his excellent research and development. A problem solved with a quick and easy solution at an affordable price. I'll put a link to his website and video in the description. The next upgrade that I think is important is upgrading your saw blade. Different saw blades are made for different jobs. For example, there are blades just for ripping, that is cutting with the grain, and blades for cross-cutting, which is cutting across the grain. And since we're doing mostly cross-cutting on the miter saw, we need to get a cross-cutting blade. There are blades for cutting specific materials like plywood veneers, plastic, or metals. There are also general purpose and combination blades that are able to handle more than one type of cut. Combination blades can both rip and cross-cut, and general purpose blades can cut through various materials like plywood, laminated wood, and melamine. How good a blade is at its job depends on things like how many teeth it has, the gullet size or spaces between the teeth, how the teeth are shaped, and hook angle or the angle of the teeth. Now we can dive deeper and talk about different teeth configurations like hook angles, kerf sizes, but there are tons of other videos out there that give you the one-on-one on saw blades alone. Just remember, in general, blades with more teeth will give a smoother cut with less tear out, and blades with fewer teeth will remove material faster, but it'll generally give you more tear out. So before you just go buy the most expensive blade, determine what you're going to be using it for mostly, and check the blade's manufacturer recommendations, because usually they'll tell you what types of materials that the blade specializes in. The next thing is more of an important tweak than an upgrade, making sure the blade is square to the fence. And the best part about this, it won't cost you any money. This is important, especially if you're cutting miters, because even a fraction of a degree is noticeable because the error is compounded across all of the miter angles. Start off by gently placing the square up to the blade and adjust the bevel until the square edge is flush against the blade. Now you don't want to push the square up to the blade too hard because that'll flex the blade and may give you a false reading. An easy way to tell when everything is squared is you'll see no light shining through the blade in the square. Then check your bevel indicator and set it to 0 if it's not already reading that. Next, we'll check the miter angle for squareness. Place a square up against your fence and adjust the miter angle until the square edge is flush against the blade. Again, gently touching the blade with the square. Now check your miter gauge indicator and it should be set to 0. If not, then set it to 0. A good way to check the true squareness of a blade is to take a scrap board, cut it in half, then flip one side over. If the two boards butt up perfectly, then your saw blade is dead on. Now if there's a gap in the front of the joint, it means that the saw blade is angled slightly to the left. On the other hand, if there's a gap in the back of the joint, it means that the saw blade is angled slightly to the right. Remember, the gap is actually twice the error of the angle. Now that you have a good blade that is square, I recommend upgrading your miter saw throat plate to a 0 clearance plate. If you're having trouble with wood tear out or small pieces getting stuck between the saw blade and the throat plate, then a 0 clearance insert is something that you may want to consider making. The insert replaces the throat plate that came with your saw. The opening in the insert is cut with the saw to the exact width of the saw blade's kerf. which helps prevent thin slices of wood from jamming in between the blade and the insert plate during the cut. It also reduces the amount of tear out that can happen when compared to using the standard insert. Now to make one of these, you'll need some wood that is the same thickness as your stock insert. First, you'll want to remove the stock throat plate because you're going to use it as a template to make your zero clearance insert. Now's a good time to clean out all of those small pieces of wood and dust that is built up inside the saw. Measure the height of your throat plate. Most of these throat plates are around 1/4 inch thick, so you can probably get away with getting some 1/4 inch stock or sheet goods from your local home store. Or if you're like me and you don't have any 1/4 inch stock or sheet good laying around, you can plane down some scrap wood to the exact thickness of the stock throat plate. Once you have the correct thickness dialed in, set the stock throat plate on top of the board and use it as a template to mark an outline. Then cut it to the width and depth of the stock plate using your outline. After that, trim the remaining edges with either a jigsaw or a sander. Next, mark and pre-drill the holes. Now, a self-centering drill bit works really good when you're doing this. Finish drilling the holes, then use a countersink bit so that the screws can sit recessed to the surface. I recommend putting a finish on it for protection like polyurethane since you want this thing to last. I'm just using some leftover yellow dye that I had. By the way, if you want to see how I make this stuff, there's a link to the video in the description below. After installing the plate and making sure your bevel is set to 0 degrees, you can slowly start cutting through the plate. And if you have a sliding miter saw, make sure you have the slide extended all the way out and cut the full length of the plate. So now that we have the zero clearance plate installed, we should get minimal, if no tear out on the bottom of the board. But what about the back side of the board facing the fence? That brings me to the next upgrade I recommend, a zero clearance fence. The zero clearance fence has the same effect on the side of the board facing the fence as the zero clearance insert plate does to the bottom side of the board. And while we're at it, we're gonna be making a stop block so that repeatable cuts can be made. And I got the idea for the stop block from a video that I saw on 731 Woodworks channel. I thought this was a great idea because his design makes it to where you do not need a T-track on the top of your fence to work the stop block. Again, this is his idea, not mine. The only difference is instead of using a 1, 2, 3 block like he did in his design, I'm just using a scrap piece of plywood. I'll put a link in the description for his video. The materials needed to do this are either an 8-foot 1x4, or if you have some 3/4 inch plywood or MDF laying around, that'll work too. 4/4 inch by 20 flathead bolts, 4/4 inch by 20 knobs that have open ends, and I would also get some 1/4 inch washers because you may need them for spacers depending on your saw design. Determine the length and height that you want the fence to be, or to make it simple, just use an 8-foot 1x4. Set your table saw blade at about an 1/8 inch high and cut a rabbet on one of the edges. This is going to be the bottom edge of the fence, and you want to do this to avoid sawdust buildup against the bottom of the fence. Now center the board on the miter saw and clamp it to the miter saw's fence. Measure the depth from the front edge of the board to about an inch past the back edge of the miter saw fence. This should give you the length of the 1/4 inch flathead bolts. Find 4 mounting holes in your saw's fence and mark them on the back side of the board. If your saw's fence doesn't have any holes, you can drill them with a 1/4 inch drill bit. A self-centering bit works best to pre-drill the holes after marking them. Then drill your holes using a 1/4 inch drill bit. You'll want to countersink the holes on the front side of the fence so that the flathead bolts can sit recessed inside of the holes. Now mount the board to the fence using the 1/4 inch flathead bolts and open end knobs to secure it. The reason that we're using the open end knobs here versus closed end is that now the exact length of the bolts won't matter in the case that the length of the bolts may be a little long. It definitely helps to use a couple of clamps to hold the board against the saw blades fenced while you tighten the board down. And the reason why I'm using washers as spacers is because the fins on the back of my saw fence are getting in the way of tightening the knobs down. After the board is secured tight against the saw fence, slowly cut into the board to create a zero clearance slot. Next, we'll make the stop block. Again, the cool thing about this style stop block is that you don't need a T-track set up on your fence. The materials that you'll need to make this are a 3/4 inch board, scrap plywood or MDF, etc., a 5 inch 5/16 carrots bolt, 2 5/16 hex bolts, a 5/16 open end knob, and some CA glue or super glue. My fence is 4 inches high, so I'm going to subtract a 1/4 inch for the bottom gap and add 3/4 of an inch for the top where the bolts will mount and slide on the top of the fence. This comes out to my stop block height being 4.5 inches high, and I'm making it 2.5 inches wide. I'm marking 3/4 of an inch from the top edge of the stop block because this is where the top of the fence lines up to, and I want the bottom edge of the bolts to line up with this mark since they'll be riding on the top of the fence. It works best to use 2-sided tape to secure the stop block pieces together since the holes that we drill need to be in perfect alignment with each other. The middle hole gets drilled all the way through both stop blocks. Set the drill depth to about halfway through the bottom block and drill the 2 outer holes. Pre-fit the 2 hex bolts into the back stop block and mount onto the fence. Use the front of the stop block for reference and mark the 2 bolts about a ½ inch to the depth of the block so they'll sit just inside of the holes. You can use a hacksaw to cut these bolts, but it'll go much quicker if you have a cutoff wheel or a grinder. After smoothing the sharp edges, which can be done with a grinding wheel or a file, take some CA or super glue and glue the threaded ends into the rear block. Then once the glue is dried, pound the carriage bolt in from the back side. So the one thing that I dislike about this stop block is that if you're not careful when butting up your stock to it, it may move slightly. And that's just because there's less clamping power on the bottom of the block versus the top. Now this is enough to make me just a little uncomfortable about this setup. Now 731 Woodworks did use a 123 block, whereas I used the plywood. And he also said to sand the back stop block at about a 5-degree bevel so that there'll be a little more clamping power near the bottom, which I did not do. So this could be why we have that slight movement near the bottom. So some solutions for this could be tighten the knob down extra tight and be gentle when butting up your stock to it. You could tighten the knob and use a clamp on the bottom. You could mount it upside down so that there's more clamping power near the bottom. You could be lazy and spend no time making this setup and just use some scrap wood with a clamp on it. Or you could use a wider front block. So I went ahead and made a wider version and noticed there was no movement. Problem solved. The other thing about this stop block with my particular saw is that I'll not be able to go to the inside of the saw's fence to get closer to the blade because the back stop block will hit the saw's fence. So to get around this, you can just make an extended front block so you can swap it out when you need it. Just rip down another longer board the same height of the block that you just made. When you're ready to drill the holes, you can use the front stop block that you just made as a template and drill guide. After you mount it on the fence, you'll want to take a scrap piece of wood and glue it to the top of the block so that it can ride on the fence. Otherwise, the weight of the longer block will make the end closest to the blade swing down because the clamping power is on the opposite end. The last upgrade that I think is really cool is this zero clearance jig that can be moved along your miter fence to cut both 90-degree and 45-degree miters with zero clearance slots. Now the benefit of having this movable jig is that you don't lose your centerpiece with your zero clearance slots when you're cutting your 45-degree miters as you would on a stationary zero clearance fence. It's also much safer to cut smaller parts since you'll have full support on the bottom and back side of the block, versus just using the stock fence where you have a large gap in the center. After searching through many videos, I came across a video on iBuildit's channel that had a really clever jig on how to accomplish this. So this is something that he came up with, not me. I'll put a link in the description for this video. The materials needed for this jig are 3/4 inch plywood or MDF, some 1.5 inch wood screws, some CA glue or super glue, and a 1/4 inch dowel, bolt, or even an old drill bit will work as a guide pin. Determine the depth, width, and height that you want the jig to be. In my opinion, the wider the better. I want mine to be 4 inches high by about 10 inches deep and around the width of my miter saw base. Start by ripping down the board for the fence to 3/4 of an inch less than the height that you want the fence to be, since the fence is going to sit on top of the base. Then cut the base to the depth that you want it. Take the end of the base that you'll be mounting to the fence and mark a 3/8 inch guideline from the edge. It's important you use glue here and not just screw it together because you need it to hold the fence in place after making your cuts in the last step. I made this mistake not thinking ahead, and what happens is after the slots have been cut into the fence, sections of the fence will only be secured by one screw and will move around. Drill and countersink your holes, then screw together with 1.5 inch screws. Next, it's time to determine which holes on your miter saw's fence that you'll use for the alignment pin. You'll need to use 3 holes for the alignment pin, and if you don't have any, you can drill them with a 1/4 inch drill bit. If you have holes already, use a drill bit to determine the size. Most likely, they'll be a 1/4 inch. With your saw set at a 90-degree miter angle, center the jig on the miter saw, lower the blade, and make a small reference mark on the top of the fence where the blade will cut. Also, make a small reference arrow on the top of the fence that's lined up with the middle hole of the 3 alignment holes. Now it's time to make sure that the jig is wide enough and will work with the 3 alignment holes that you plan to use. Swing your blade to the right to a 45-degree miter, move the jig to the right, and line up the small reference arrow to the right outer hole of the alignment holes. Lower the blade and draw a reference mark as to where the blade will cut. Next, swing your blade to the left at a 45-degree miter, move the jig to the left, and then line up the small reference arrow to the left outer hole of the 3 alignment holes. Do the same as before and lower the blade and draw a reference mark as to where the blade will cut. After doing this, you'll have a visual of where your miter cuts will actually be on the fence. Now go back and center the jig on the saw and make sure the small reference arrow is lined up with the miter saw's fence center alignment hole. Trace the outline of the alignment hole on the back of the board. Make sure to be accurate here because you want the hole that you drill to line up exactly with the alignment hole in the saw fence. Set your drill depth to about half of the board's thickness and carefully drill, making sure to line it up as best as you can with the outline that you just marked. Place a mark on the guide about an inch or so from the edge of the saw fence because this is going to be your cut mark. Make a cut at your mark. Obviously, using a dowel would be the easiest thing to cut. Here I'm just cleaning up the sharp edges on the guide pin. Place some CA or super glue in the jig hole and glue in the guide pin. Once the glue's dry, take your jig and slide the guide pin into the center of the 3 alignment holes in the saw fence. At this point, if you've done everything correctly, there should be very little to no movement in the jig. Before you make your first cut, make sure your miter is set to 90 degrees and set your blade stop so that you don't cut the base of the jig in half. Lower the blade and slowly cut into the jig. Next, swing your blade to the right at a 45-degree miter, then slide the guide pin in the right outer hole of the 3 alignment holes. Lower the blade and again slowly cut into the jig. Now swing your blade to the left at a 45-degree miter, and then slide the guide pin in the left outer hole of the 3 alignment holes. Again, slowly cut into the jig. And for those of you that stayed till the end, I really appreciate you sticking around. And feel free to leave a comment on what you thought, or if you have any other ideas for miter saw upgrades.